Hey everyone! Welcome back to Bug No Jutsu, your favorite channel where we blend coding with cool vibes, anime style. Today we're diving into a very interesting and deceptively simple problem from LeetCode 2138. Divide a string into groups of size k. This is a common interview problem that seems easy at first glance, but it offers a lot of opportunity to think about edge cases, memory handling, and clean logic. Whether you're preparing for LeetCode grind, coding interviews, or just want to improve your Python problem-solving skills, this one's a must-watch. So grab your snacks, sit back, and let's break it down like a pro, ninja style.
The problem gives you a string s, an integer k, and a character called fill. You're asked to divide this string s into groups of length k. Here's the process. Start from the beginning of the string. Take the first k characters, that's group 1. Then take the next k characters, that's group 2. Continue this until the string is fully processed. But there's a catch. If the last group contains fewer than k characters, you are required to fill the rest with the provided fill character. And finally, return all the groups as an array of strings. So the final array should contain complete groups of size k. The last group padded with the fill character if necessary. Sounds simple, right? But it's a great exercise to test. Loop controls slicing logic, edge case handling. Let's think before jumping into code. There are a few observations we can make right away. Group division logic. You are slicing the string every k characters. So you can think in terms of indices, 0 to k minus 1, then k to 2k minus 1, and so on. Handling the last group. If length of s% minus gram k not equals 0, then the final group will be shorter than k. In that case, the fill character must be repeated for the remaining length to make it k. String slicing. Python slicing is powerful, so using s of I:j lets us extract exact substrings easily. This problem gives us a real-world feel. It mimics formatting strings for UI display, encryption groupings, or even pagination logic. Step 1. Initialize variables. You start by preparing an empty list to store the result groups. This will eventually hold all your k-sized substrings. Then you create two pointers, I, starting index of the slice, j, ending index of the slice, set to I plus k minus 1. These pointers help you iterate through the string in chunks of k. Step 2. Main loop to slice the string. Inside a while loop, you keep slicing the string from index I to j inclusive and appending it to your result list. This happens until the starting index I goes beyond the string length. You cleverly update I and j after every iteration by adding k to move to the next chunk. This chunking method ensures you process the string in fixed-size segments, just like how a ninja split scrolls into parts. Step 4. Return the final result. Finally, you return the list of all groups, now fully processed and padded if necessary. Simple? Yes. Effective? Absolutely. Bug-free? Like a true shinobi coder. Time complexity? O of n, where n is the length of the string s. Each character in the string is visited exactly once. You're slicing substrings using Python slicing, which is done in linear time for each group. There's a small additional cost at the end to check the length of the last group and pad if needed. In total, the number of operations is directly proportional to the length of s. Space complexity, O of n. You're storing the resulting chunks in a list, and in the worst case, you create approximately ceil of n divided by k substrings. Since each substring is of size k, the total space used will still be proportional to n. So your algorithm is very memory efficient and handles even large strings gracefully. Key insights and takeaways. This problem reinforces the importance of precise string slicing and edge case padding. It's a good practice problem for handling partitioning and understanding data formatting. The use of two pointers, I and j, makes your logic easy to follow and avoids nested loops. Padding logic must always be isolated at the end. It helps to avoid overcomplication during iteration. It's also a problem where clean code matters. Your solution is compact, readable, and robust. And there you have it, ninjas. That was an in-depth walkthrough of LeetCode Problem 2138.
Divide a string into groups of size k, a simple yet elegant challenge that teaches you solid coding principles. We broke it down step by step, analyzed the time and space complexity, and highlighted key insights to help you master problems like this with confidence. If you found this helpful, don't forget to like the video, subscribe to Bug No Jutsu for more dev content with an anime twist. Drop a comment below if you want me to cover your favorite coding problem next. And remember, real devs don't just write code, they master the art of solving problems like true shinobi. Until next time, stay sharp, keep coding, and unleash your inner jutsu.